You're listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson of Protein Machining, and this week I'm joined by Zach Smith. Zach, welcome to the show.
Thanks, Dylan. How you doing?
I'm doing great. How about you?
I'm doing all right. Just getting my day started.
Awesome. Well, so for those who don't follow you, where can they find you online? What do you do? All that good stuff.
So my name's Zach Smith. You can find me on Instagram, Zach S. Miami. I own a company called Our Precision, specialize in making small watch parts and venturing into making parts for other industries requiring high precision. So like medical prototypes, it's my latest venture.
Okay, very cool. Very cool. I mean, you have the right machinery. So before we get into your backstory and all that, what machines do you have? What is Our Precision?
So we have two Kern CNC machines. We have a HSPC and a smaller MMT, which is their desktop variant. And have some smaller CNC machines that I started off on. They're called Emco Meyer.
Okay. I'm familiar a little bit with them.
Yeah, cool.
Well, then how did you get to where you are now? How did you get the manufacturing bug?
So it's kind of a unconventional story. Started off, do you want the long story or the story or the short story?
I mean, as I said last episode, this is the In the Weeds podcast. Let's hear the long story. What made you travel down this route of both, very interesting machinery and some interesting machinery repair and, all of this stuff?
Okay, so I'll start from the beginning. I grew up in Miami, Florida, and I've been a serial tinkerer since I was a really young kid. Love electronics, mechanical things, and naturally watches and machining kind of fell into it. So basically, my dad was a banker, so no mechanical skills whatsoever. Like gave me a screwdriver and like an Allen key. And that was it.
Okay.
So I'm self-taught from the beginning. I was in my sophomore year, and a family friend, he introduced me to a friend, Eddie, who owned a jewelry store. And Eddie, he taught me how to repair these electronic heart monitor watches called Polar. So I did all the repairs there, mostly changing batteries and replacing broken parts, and got kind of boring after a while. I'm really ADD. So
was this just a job for you at that point, or were you like,
it was just
where did
a
you
job.
get this tinkering mindset from? Because like for me, my dad, owned a bunch of businesses making wood stuff as, a young adult, and we were constantly fixing things as a kid. So like I knew kind of where my path would go. But like if you grew up in a household where that wasn't the case, like what tripped that trigger where you were like, oh, I need to make stuff?
I don't know. I kind of just took stuff apart as a kid and put it back together. And it all kind of I was just always really curious, like, how does it work? It was like always asking why. And it drove my parents nuts because the worst thing is like when you have a kid that's just annoyingly asking why all the time and you don't have the answer, or you just don't want to hear it.
Right. Oh, yeah. Especially if you don't have the end. Yeah, exactly. If you can't be like, oh, here you go, shut up. Yeah, that must have been tough for sure.
Exactly.
All right. So you're fixing these Polar watches, and then where did it go from there?
So fixing these Polar watches, really bored after doing it for a few months. And so eventually I started figuring out how they worked. I had some electronics experience prior. And so soon I was repairing the circuit boards, finding the faults on them and when they were supposed to be replaced. And of course, my boss loved it, since now he could make more margin on the refurbished parts, and I was happy to do something fun.
Right.
So after about like 2 years of doing that, I found my replacement, and he asked me if I wanted to work on Rolex simultaneously. So of course I said sure, and he showed me how to polish the cases, bracelets on used watches he'd buy from customers, and then he'd resell them on eBay.
Okay. So not really an internal refurbishment, just kind of cleaning them up and making them look nice.
Exactly. Yep.
Okay.
So during my employment there, so I'm still in high school, my best friend Kevin Grow and I would work in his garage, and Kevin was like a whiz at all things mechanical. And so we'd be rebuilding ATV engines, dirt bikes, Jeeps, and I really, really got into that. I love cars, love bikes. So he literally showed me everything he knew. And that's what really led me to doing what I'm doing now. So it was like, this was the spark, you know?
Okay. Okay.
So one thing led to another. Those rebuilds then led to me getting more curious about stuff. And that led to TIG and stick welding. And then, we'd get heads back and cylinders from the machine shop. And I'm like, well, how'd they do that? That looks pretty cool. Shiny.
Okay. Yeah.
So after a lot of research, I bought a Bridgeport 2J mill and a Logan lathe from a retired gunsmith. Thankfully, my parents, they let me put it in their garage and started making all kinds of things. So
those are some good machines to start on too.
They were great. I wish I still had them today. It's just, unfortunately, when I moved here, I'll get into that in a bit, but it would just can't fit that in an apartment.
No, definitely not. So you were making stuff on these mills and the lathe, what was next?
So then that turned into buying an old Emco Meyer CNC mill on Craigslist, broken. It's from like the 90s. And lots of research and reading. I love looking into nerdy electronics projects and stuff. So this kind of fell right into that. And sure, what comes next is retrofitting it. So
of course, yeah,
makes loading sense. It up with Mach 3, and so I'll come back, but I'll come back to this. So after like working on Rolex in the jewelry store for like 2 years, I met another wholesale dealer who started giving me work to polish lots of watches, and that led me doing work for him full time. And when he wasn't looking, I'd fix simple things in watches, like if it wound rough or it wasn't timing out on the machine, I'd figure out how to adjust it. And so when he found out that I was doing this, thankfully he didn't get upset. And he asked me if I thought I could service a watch. And so never having done that, I took it apart little by little, figured out how it went back together, and then used some oil that he just had in the drawer, like some watch oil. And then that first watch turned into hundreds over a year. And with the help of a friend of mine, Hermes, he's a certified watchmaker, he showed me the Rolex way of doing things correctly. And then that led to working like crazy hours. So I was doing like 80 hours a week from 2013. Yeah, it was rough. From 2013 to 16. And then they were like, it was like trying to spend all my time figuring out how to fix the problems that would arise after, not servicing a watch for 5-10 years, whatever. And so my boss confronted me one day and he goes, what do you think about going to watchmaking school? So didn't take any thought. I was like, I would love to do that. So applied for the WOSTEP school, which stands for Watchmakers of Switzerland Training Education Program. So it's like an industry certificate. So I went to school in Miami. So real easy, didn't have to move anywhere.
And that's a pretty big watch industry there in like Florida. So it makes sense that there is a branch of it there.
Yeah, lot of watchmakers there. So after getting into the school, we worked on, we started off in micromechanics, and this is why I'm getting into this, because it really gave me a starting point. So we learned how to file, sharpen screwdrivers, gravers, use a lathe, drill press, milling. So it was started off in the garage. Now I have more of a structure. It's understanding feeds and speeds, that kind of a thing where starting off just I'm listening to it. How does it sound? And right. Turn it faster or
which is not a bad way to start, though. I mean, I think that's possibly missing in a lot of people nowadays, because so many people jump right into CNC and they've never touched a hand wheel, and then they don't know what the feel of a bad cut feels like.
100%. I think it's invaluable to start off on manual equipment. Yeah, learning how to understand how materials behave with brass. I never cut brass before that. Using really small end mills, like 0.2, 0.3 end mills. So after sharpening gravers for, I think it was about a month from 7 a.m. to 5 p.m. every single day. It was like hands like ready to fall off.
How long is this program before we go on?
It was 2 years. They reduced it
Wow.
now. Unfortunately, we were the last class to have micromechanics.
Oh, that's too bad.
Yeah, it's well, there's two ways of looking at it. I guess, the way they look at it and the way that watchmakers or people looking to get into it look at it. So,
Right. Yeah, I'm sure there's a lot of people anxious to get to the watch part, whereas, I think it's probably how I view a lot of these people skipping learning G code and, manual machining. It's
yeah,
like, yeah, but that's like the basis. Like you got to get into that first.
100%, 100%.
So you were sharpening gravers, and then what's the next step in that program?
Yeah, so we were making balance staffs. This is when it got challenging. So for people that don't know, if you look in a mechanical watch, there's a little wheel that oscillates back and forth. It's called a balance wheel. And the axis of it, or the axle, is called a balance staff. And so we were making these balance staffs, and the pivots on the end of it, they're 0.1 millimeters. So what's tricky...
They like break if you look at them wrong. Like
exactly.
Before we go on, if you are listening to this podcast and you're a machinist, go get like a $10 mechanical watch off of eBay and just take it apart. Like you don't worry about putting it back together, but like just to see the level that you can machine to as far as size. Oh my goodness, it will educate you on really. It's just insane. It's insane that there's that much going on inside a little pocket watch or a wristwatch or something.
Definitely. It's pushing the edge. So what's tricky is you get to like 0.11 millimeters and the rest of it has to be burnished down with a carbide burnisher down to 0.1.
Oh my
so
goodness.
If you don't use enough oil or you put too much pressure on it, snap. So like after 2 hours of machining this thing, it's gone. So it was interesting. And the crazy thing is, so the way we turn these were on hand turn lathes. They weren't even on engine lathes. So there's a company called Oria, and Swiss company, and you're cranking this wheel with your left hand and then holding the handheld graver with your right hand. You're not even using a cross slide, and you have your loop. So you're like looking at this thing under magnification, and you're physically seeing like how much is 10 microns or how much is 20 microns of material after you mic it, and then you come back to cutting it. So it was really, really good for understanding how to make small parts, especially without a cross slide. That was pretty wild.
That's crazy. I had no idea. I assumed it was a hand turn, but I didn't realize that you were then hand holding basically the cutting tool. Like,
yeah, that's just on a tool rest.
Wow, that's crazy.
So like it's between centers. There's like a little lathe dog, like tiny little finger and there's like a carrier that it drives, and it was interesting. The hard part.
How many tries did it take for you to produce your first good one?
Oh man, so many. It was so humbling.
I bet.
So humbling. And it was like the exams are tough because you had to make a balance staff in a short time frame, and you're graded on the dimensional accuracy of it. So all the drawings were random on the test. And so the teacher would give each student a different drawing. So it's not like you could just like sneak one in your pocket and be like, look, I made it.
Right.
And or practice making the same one over and over. So,
oof.
So anyways, our second year was training on making hairsprings. So the spring that goes around that wheel. So it would come already formed like in a spiral, but it didn't have a collet in the center and it didn't have a stud to attach to the bridge. So we learned how to form the hairsprings, how to attach the collet to the center, how many coils you required, the length of the spring, how to vibrate them. So it was really the best year because it was really theory involved. And that was the thing I was lacking the most. You might know how to do something practically, but if you don't have the theory to apply to it, it's like half the battle.
Right. Yeah. You can't adapt to anything if you don't know the foundations.
Exactly. So we learned how to disassemble movements that second year, clean them, lubricate them, identify the faults, learn about gear profiles. So theory was definitely like the most valuable takeaway. But okay, so back to the Emco Meyer. So eventually got it working the way I wanted after hours of work, just measuring bad parts, and had no idea how to use CAD CAM. I was just so green. And I met a guy through a family friend. His name's Adam Garabello. He doesn't have it. He has an Instagram page, but he just doesn't have his work on there. But he's crazy, this guy. So he's third generation machinist. Blows my mind with some of the setups he's done. He makes a lot of aircraft parts and a lot of really precise large parts. And so he showed me the basics with CAD CAM. So using Fusion 360, it was like the Mac of CAD programs, right?
Right.
And so from there, I started drawing parts or watch parts in my last year watchmaking school. And I used a toolmaker microscope making point clouds. So XY coordinates, and then
Oh, wow.
just connect all the dots, measure it a few times, generate an average, and then you have your part.
Oh, boy.
So
That's some, I mean, it sounds like everything up to this point, you are excelling in painstaking work.
I'm a masochist. I like to spend a lot of time. I love learning stuff, so it's been a fun journey up to this point. But anyways, so I'd machine these watch bridges and other parts in my parents' garage on this Emco. It was like not crazy accurate, but it was, you made enough of them, and then maybe you'd get one or two good ones. So anyways, after school, got hired to work at Omega, and it's a watch brand for any of you guys that don't know it, and learned a ton about how watchmaking works, like in the industry, like corporate wise, and that was really valuable. And it was wild.
That's really cool. Oh, that's
Yeah,
really,
it was
cool.
really crazy experience. So how it was so different, just struggling to get parts, working for like private companies, and then now I'm in this place that's like the ivory tower for some people, and there's a whole drawer of parts just right there. You can just go grab it. So that was pretty awesome.
That's really cool.
Yeah, it was cool. But the time came. I loved my experience there. Learned a ton. My wife got accepted into veterinary school in Columbus, Ohio. So it was an easy decision for me just to jump ship and take a risk. I looked for machine shops to work at in Columbus because there's no watch companies here. Wasn't going to work at a jewelry store again. And so after about like a month, I found like a potential place that would probably be good for me because I had like a decent amount of experience, but I didn't have job shop experience. So
Right.
got an interview lined up, came here at the same time she was looking for a place to stay for school and stuff, and it all lined up. The place hired me. It was an hour away, so an hour drive both ways.
That's a little tough for sure.
Yeah, but I was, willing to take it,
Right.
Screw it. $20 an hour. So wasn't going to complain. I got to learn a lot and learn how a job shop works. So that was really cool. So they took me on there actually. So this is pretty crazy. So there was a lead programmer there. So it's just like this machine shop in kind of like rural Ohio. And there's a lead programmer who is manually programming all the parts. So on a lathe, it's one thing, like it's
right.
Lathe programming, no big deal. But
manually
on a mill,
programming? Oh my God.
He was programming parts manually on a mill. So like,
oh geez,
4 ops, crazy. Like, so we were making parts like for like blowing resin for fiberglass. So it's like these big assemblies. There's nozzles that go along these round tubes, I guess, that they would just like the fiberglass would go through the center of it, and then the resin would blow out from the sides and cover the fiberglass, was my understanding of it. I never actually saw it work.
Okay.
So the nozzles were a pretty complex part to machine, even like programming it in the CAD program, or CAM.
Right. So the fact that he was doing it manually was crazy.
I was really impressed. I was like, man, this guy, he is, and he would just sit there with his headphones on, just banging out on the control with his fingers. And I was like, man, this guy's nuts.
Oh, and he would program at the control. He wouldn't
At
even
the
program
control.
on it like a computer on a notepad or something.
No, on a FANUC control, just banging it out with his fingers. And I was
That
like, man, this.
that's a lost art. Yeah. The teacher who taught me G code did that for years until CAD CAM kind of came around. But yeah, he told us
Wow.
stories of, just sitting there, little armrest, just sitting there, kind of programming. I think they had Fidals maybe or something. But yeah, it's definitely a lost art.
That's crazy. It blew my mind. I was like, there's no way. Like, why in today's time, like with what we have, I was like, man, forget this.
Right.
So, and I do know G code. I can program simple things, but it's like, oh man. So, anyways, I basically got hired there to write a post processor for all their machines, and they're using Bobcad, which I hate. I don't want to bash anyone, but complete nightmare to use. And basically digitize all their drawings that they had, make them into 3D models. And that way, if the lead programmer goes away, they have some type of way to keep running the shop.
Right. Yeah, that's a big problem. One of the guys I program for locally, he's a friend, and that's what kind of happened to him is he had a programmer who was an older guy kind of doing it as his like retired job, and I think he passed away or something, and then now he's like,
Man.
I don't have like I don't know what these programs do. He's like, this guy was the guy who told me like, oh, run this program for these parts, and so now he does this exact same thing. He's like, can you digitize this, or here's the model, can you reprogram this and kind of update it and use adaptive clearing and stuff? Because I want to say the other guy was using Mastercam, but even then he was like, it was like X2 or something, super super old Mastercam. So
Wow.
yeah.
Wow. X2.
Yeah, it was quite a long time ago, and I think it was like his personal license or something. I don't know. Like he doesn't even have a license of Mastercam to view the programs anymore. He's like, I have the old G code on floppies, and he's like, so if you could just like update this so I could actually like repost it when I need to, that'd be great.
Wow. So floppies even work.
That actually, yeah. One time he called me because he's like, my machine's down, it won't read any of these floppies, and I was like, dude, replace that floppy drive with a USB drive, please. Like they make plop-in ones, and he was like, what? And I like sent him the links to it, and he did it. He's like, oh, it worked. Like I can run again. I'm like, awesome, thanks.
Nightmare. I lost. Well, that's a long story with the M codes, but there was software that came with it, but the floppies didn't work anymore. So that was fun.
Oh, geez. So you were digitizing all these parts and prints and everything.
Yeah, digitizing some of the parts. I was able to write a post processor for, I think it was the FANUC, the OT control. And so it was the OT, and then there was the OM for the mill. So I got those written out, and they were like 90%. Drew up one of the drawings, was like a double lead screw part for a garbage truck, and with an eye on one end. And posted out. And so go to run it on the machine, and he's just coming up with all kinds of reasons why it's no good. And it, in all fairness, there were some things like the lead in and lead outs were too long, and there were some unnecessary moves, but the program ran. So
right, yeah,
there's a little bit of like, this guy's taking my job. I don't know how to use CAD CAM in the mix. So
right, yeah, sounds very much like we've always done it this way and we haven't had problems, so why change?
Yeah, that's exactly what it was. So after 3 months, I'm like, you know what? I'm running machines during this time period because I've just basically been pushed out, and the boss wanted it. He's coming to me saying, why isn't it done yet? And then I'm dealing with my coworkers. I'm trying not to start a fire there. And so anyways, I'm like, I got to get out of here. This just isn't going to work out. So I decided to start a business in spare bedroom of our apartment. And I had 3 CNC machines in there at that point, 3 Emcos. So one was the retrofit, Then another one was one that I revived using the original FANUC control because very quickly I figured out how much I hated using Mach 3 and Mach 4. That's another story.
I
But
don't blame you. I've never run either of them, but I have yet to talk to a single person who's like, oh yeah, love the Mach series of programs.
it serves its place, you know?
Right. Yeah.
And so I'll say that. But so got two more machines. I ended up driving out to Pennsylvania. There was a guy that got them from an auction from a school. So it's a lathe, small lathe, and a small mill. And I ended up finding someone with like a hard drive to then take to a recovery center, and was able to take two hard drives and piece the program back together. It uses a program called WinNC.
Oh
And
man.
it was pretty challenging. And the hard part is like machine parameters and stuff. Like, is it the same machine? Is it using the same drives like servos? Like there's, I mean, as you know, there's so many variables once you start coming down to it. And so I went to a data recovery center. I was able to piece the stuff together, and I ended up getting the mill to work, and the lathe still was dead. It uses a proprietary like RS485, like a, what is it?
Jeez.
So like the PCI cards that would normally go in a computer, I had to get a computer from Windows 95 to even be able to plug a card into it. And then I had to find a card. So luckily, someone had this card. It was made by Emco in Cincinnati. He drove up, paid him. And so I ended up like just piecing all this together over the time span of maybe a few months, and got it working. Long story short. So I'm in my apartment, 3 CNC machines there. The retrofit has a high-speed spindle. I retrofitted on it, an NSK spindle. So I'm able to like run really small end mills, like 0.3 millimeter or 0.2, and actually machine like small fly cutters for gears, machine gear profiles. So I'm servicing watches for local jewelry stores out of my apartment, basically. And whatever parts I can't get, I'm making on the CNC machines. I didn't know anyone that I could just call up and say, hey, I need this complicated part. A, because it probably wasn't worth their time to make it. And I really enjoyed it. So it was one of those things where it wasn't worth the money, but it was worth the knowledge to figure it out. Does that make sense?
Right. Yeah, totally.
So that went on for about a year, and I quickly outgrew this space. I mean, if you saw this bedroom, it was like a sardine can. And
I bet. Yeah. Just 3 machines alone, not including any other support equipment you had.
My neighbors loved it.
I'm sure.
Thankfully, the upstairs neighbor was so loud that it just kind of balanced each other out. He'd make a lot of noise. I wouldn't complain. I'd make a lot of noise. He wouldn't complain, I guess.
Yep. For sure.
So moved out of there, found an office space. So there's 2 office suites. One suite was for the machines, and the other suite was to keep clean for watchmaking. So it made a lot more sense. And outgrew that space in 2 years. Then I moved into the space that I'm in now. So it's 1,500 square feet and has a decent sized warehouse, 3-phase. I'm running out of amps, but
I know that feeling for sure.
yeah, I feel like that's the common problem among us all.
Yeah. It's like, why didn't you put more than like 100 amps a 3-phase? Like, come on, that's not that much. So what was next? I mean, how did you get some more eclectic machinery?
Okay, so that's coming. So basically, so I move into this space, and my biggest issue on the Amcos is, sure, you can mic parts out, right? But some more complex geometries, or like bores, for instance, or positioning of them. And I was doing this on a toolmaker's microscope that I built, and I wasn't 100% confident with what I was getting, because, you know, I made that. So how accurate could it be? And so I found a Kern IM series for a deal. There was something wrong with it, of course. And so I decided to buy that before any kind of CNC machine was going to come in.
Smart. Very smart.
Thanks. And so it got here. I had to fix it because the hard drive was just completely corrupted. could not get anything off of it. Tried to do the revival thing and no luck. So I wouldn't go past the BIOS. I'm thinking like, oh man, I got all this money tied up in this thing and I paid like a decent amount of money for it, and it's not going to work. Long story short, I found another control, was able to mirror the drive, and it worked. Was able to take some calibration gauges, put it on, measure them, measure some more complicated parts, and it was accurate. So then fast forward like a few months, and my story with Kern started. So I met Dan DeMazure, who I'm sure many know on here. His episode was really fun to listen to.
Yeah, and he's submitted some questions we'll get to as well.
Oh, cool. So I actually met Dan through a really good friend of mine. His name's Brad Taylor. He's an incredible watchmaker, by the way. Check him out. And so Brad was informed through Dan that there was a Kern MMT available in Silicon Valley at a tech company, and it was broken. So Brad
Sounds right
told
up your alley.
Yeah. Man, so when Brad told Dan he wasn't interested, Brad was like, I know someone who might be interested, and then reached out to me. And so I looked at the email, and like in 30 seconds, I'm like, screw it, I'm going to take the risk.
So did you know about Kern by this point? Because I guess
yeah.
they're pretty well known in the watch community, right?
Oh, yeah. Well, because of the Hackos, like
Okay.
Josh Hacko, like the stuff that he's doing in Australia, I always looked at, I was like, man, the stuff this guy is doing is insane. And
yeah,
always,
I mean, that was my first introduction to them, was John Saunders' tour.
That was a great video.
Yeah, and like both him and Grimsmo, I think, had talked about Kern, and like I was like, I've never heard of this, and they're supposed to be so accurate. And then I started going down the rabbit hole. I was like, oh, these are cool.
Really wild. It became like that. It was just like my dream machine,
Right.
I'm sure like many, I was just like, never going to get this machine. It's just not going to happen. I'm going to work a long time before I do. So, getting this email, I'm like, I'll do whatever it takes to go there and get this thing.
Right. Yeah. Sign me up.
Yeah, exactly. So I contacted the tech company and I told them I'd take the machine and I'd fly out and be there July 5th. So I booked my flight, hotel, organized the freight company, the trucking company to take it back as a single load, and material lift and stuff. So I'm like, okay, I'm just going to go pick this thing up. It's all going to be fine. And I got a call from Dan and Tony Marigold. And Tony he's the man. Like he really, like, if it wasn't for him, I would have screwed this whole thing up, hands down. There's no way. So,
oh, really? Okay.
Oh yeah. So I'm like, I'm just going to pick this thing up from the bottom. It's a benchtop machine. Like, it's going to be easy. And Tony's like, no, you're going to take the enclosure off. You're going to disconnect all the wires. Then you're going to pull the casting out of the machine, out of the enclosure. And so he gave me like step-by-step instructions. You can't transport it with the spindle in it. So I'm like,
wow.
okay.
That's crazy.
Yeah. So it was like 3 days of work disassembling and getting it out of the place with a material lift, truck took it back home. So flew back, started unloading the truck when it arrived, and the machine was just in a complete state of disarray. Like not from travel, but just it was in use for 22 years and it needed a serious overhaul. So like all the airlines were shot, Festo solenoids were messed up and cracked, and the electrical was pretty bad. That was actually what was wrong with it. It was the customer was complaining about a 24-volt issue. So on the plane ride there, I was like, I read the Heidenhain manuals from front to back. I found the service manuals, and I'm like, 24-volt, it has to be the emergency circuit or something that's not giving, if 24-volt doesn't work, nothing turns on. So
right.
I ended up going through the machine. I replaced all the airlines. The Festo solenoids weren't available anymore, so I had to repair some of them. I'm not going to get too into it, but I was able to repair the last link in the problem by machining a part and then just screwing it into it, which basically air was escaping from.
Oh, interesting. Okay.
Yeah,
we had to do something kind of similar on our Kitamura. The solenoids you could find newer versions of them, but they weren't quite the same. And the only thing that was leaking was like it was either a very hard rubber or a very soft plastic gasket in them, and we could not find it anywhere. And like
That was
thankfully,
exactly the issue.
yeah, I think we found some on eBay and just cannibalized the gaskets out of those because they were better than ours. But yeah, it was still, even when we sold it, like we were always just kind of like, holding our breath, like, is another one going to go out? We don't have any more. This is it. Like,
It's tricky. Like, what do? You just got to try and find what works, and if it works, it works.
yep.
So the issue basically is there was such a bad leak that the control was saying low air pressure, and there's no air pressure since it blows air into the area where there's the glass scales, and spindle pressure, or since it's air cooled, the spindle, there's no air coming through it. Machine's not going to move. So between that, and then there was some faults in the wiring in the emergency circuit. So, there was a handheld pendant, and this thing was just like thrown around. And there was like the start button. They had soldered a wire like a push button coming out of it. It was just like, I didn't really understand why, because the green button worked fine. So I was like, anyways, so cleaned it all up. Took like a week. I got it running, made some test parts, threw them on the keys. So outer diameter, inner diameter, interpolate it, drill it. So like positioning errors, and to see if there were any positioning errors. And mechanically, it was pretty good. Made some minor adjustments, and after a little back and forth, it was bang on. So 3 months goes by after getting the MMT. Love this machine. It's fantastic. And Dan and I are chatting on the phone one day, and I was just thanking him for telling me about this deal and how it changed my life. And he tells me, he goes, well, you see another machine you might be interested in. And I was like, oh, here we go. So he says we took it in HSPC and tested it, determined it wasn't necessarily bad, but we don't want to put a warranty on it. So I'm like, okay, thinking about it for about a week. And then I call him back, and we agreed on a price. And so 3 days later, the machine shows up on a semi, and it's being unloaded into the warehouse. And finding a rigger in 3 days, it was like, so I called a local company, like the first company I called. I was like, hey, so I need a rigger to be here Monday. And this is like on a Thursday or so. And she goes, huh, you're funny.
Oh no.
And I'm just like, man, this thing's on the truck. It's already on the way here. And I'm really in trouble because I don't have a forklift. And not only do I not have a forklift, I've never rigged a machine that weighs as much as this. I was like, oh man. Anyways, got unloaded, total game changer now. It was just basically being a hobby machinist in my parents' garage and my apartment to having a capable small scale machine shop. There's 5 CNC machines here. Kern M series, fiber laser, fully built out watch workshop with the same equipment as the service center I worked in. So now I'm making parts for other brands, watch parts for in-house repairs that can't be obtained. And then, as I said in the beginning, venturing into medical parts with 2 local medical device companies. And I'm looking to expand that side of the business since it's really fascinating and very challenging.
I bet. Yeah. And like you said, job shop work is very, very different than, your own product or, repair work or anything. I mean, it is a very bizarre industry to be in.
It definitely is. Definitely.
Were there any teething issues with the HSPC, or were you able to hook it up and go pretty much?
Pretty much hook it up and go. Yeah.
That must have been a nice change for you.
Oh, it was great. It was great.
Just be able to put that right into service.
Man, it's what's mind-blowing is both these machines are from 2000, and it's crazy how accurate they still are. And it's like a true testament to like how good Kern is. It's coming from using like I used a brother in the machine shop, or using these hobby machines. There's just no comparison.
Yeah, I'm sure. Glass scales and good build quality really are game changers.
For sure.
Well, let's get into some of the questions.
Sure.
Your friend and my, Josh, he asked, how does your experience in watchmaking inform your approach to machining and manufacturing? What skills translate over from one trade to the other?
So I would definitely say that, the precision involved in watchmaking, everything has to be perfect. And as we know, nothing's perfect. But it's just, if it's intolerance, then it's good. But that chase of perfection, nothing's good enough, has definitely helped me out and set me back because throwing away perfectly good parts, but it's definitely helped me make better parts in the machining world for sure.
I'm sure. Yeah. It's such an interesting trade where, like, yeah, there is a tolerance, but like the better you are, the more the watch functions how it's supposed to be. Like for me, like I can be, if I got a plus or minus 5 thou dimension, they probably don't care. But like for you, the better towards nominal you can be, the better or the easier the rest of your job can be, I would imagine.
100%. Yeah. Especially with like a balance wheel. It's got to be perfectly balanced and it saves you time if it's dimensionally accurate.
Right. His other question was, what job has taught you the most?
So that's a tricky question. I've not worked anywhere for like 10 years. So moving from job to job has really given me an advantage of learning a little bit about everything. And I would probably say I've learned the most on my own. And the only reason why is because it's a need to survive. Like, I'm an avid researcher, like researching stuff online and having to solve problems to then be able to pay your bill at the end of the month it definitely puts some fire, under you. And
For sure.
so I would say like working here has been the most challenging. But if I had to say a job that wasn't here, it'd probably be working with my second mentor, the wholesale guy.
Okay.
I learned the most about Rolex there.
Well, then let me rephrase that question or change it slightly. What job have you taken on in your shop? Like, what parts have you made that have taught you the most?
Probably there was a watch project for a brand called Orion, and I had to make so it's tricky. There's with watch dials back in the earlier times before CVD, like chemical vapor deposition, they were color treating dials, as the Europeans call it, galvanically. So like through electroplating. And the Swiss watch industry is incredibly secretive, and they don't like Americans, getting involved too deeply into their business, from how it seems, anyway. And I needed a way to change the color of brass without applying paint to it, because if you have a really cool surface finish, like say you wanted to apply like an engraving and you wanted to see the rainbow pattern that would come off from using like a cutting tool, if you paint that, it covers up that pattern or that effect. And in this case, in the pattern, there was a rainbow effect, and the top of the dials were mirror polished. So had to somehow get color on there without covering it. So I spent 3 months making a chemical process in-house for galvanically treating these dials to be able to apply an interference color to them, kind of like titanium anodizing.
Wow.
So you take brass, which is yellow, and you can turn it, it starts turning from yellow to champagne, and then from champagne to brown, then from brown to purple, from purple to blue, then from blue to gray, and then it gets darker. And the colors just repeat as long as you leave it in the bath. So it was really challenging because there's a lot of variables. I'm not a chemist. So, having to understand temperature gradients in a beaker, for instance. So using jacketed beakers and then buying some scientific like chillers that could keep stuff between like 0.5 degrees Celsius plus or minus. And so basically understanding the temperature of the solution, current density. So you have your part, and calculating the area of the part. So how many amps per decimeter squared, does it take to apply that surface coating onto your part? And then coming up with a few inventions along the way using Arduino and finding a way to spin the part or be able to knock nitrogen bubbles off of it because they were causing striations. So that was really challenging, and it worked. So after 3 months and a ridiculous amount of time, I was able to develop this process to work in-house. And I did 4 of the dials, and the rest were done in Switzerland because we were just running out of time. There was a deadline. So I would say that was the most challenging project. And the takeaway was surface treatment, learning how to keep parts flat. That's when I switched from using a fixture plate with alignment pins to System 3R. So I learned a lot about surface flatness, because if you try to engrave a pattern on an uneven surface, half the pattern's engraved, the other half isn't. So,
Yep.
And then also taking the part off the machine and putting it back on. That was a big one. So that was the job I learned the most from, for sure.
So how do you balance your time when you're developing a process like that? Because I mean, you still have to make money and like pay rent and all that. And like, it sounds like you are very similar to me and some other people I know, where when you start down a rabbit hole, that's all you want to do is work on the rabbit hole and keep going deeper. And, it's kind of hard to break away and do the things you have to do versus the things you want to do. So what tricks have you developed to kind of keep your workflow going through the shop while you're getting to deep dive on the things that you want to learn?
It's a fantastic question. So it's quite a challenge for me because I have very, very, very bad learning disabilities. So I'm like super ADHD, and I have to set a timer or figure out how long I have to work on something. So if I have 3 hours, it's got to be 3 hours and not just one more thing, because that one more thing just becomes the rest of the day.
Yeah,
and
for sure.
using spreadsheets to keep things organized. So I keep all my jobs organized and color coded. And there were some jobs that I fell behind on during the process. It's inevitable, and I had enough money set aside. So when there was a week where I had to take off a whole week to do something, because there was it was probably like 2 or 3 weeks that I had to just devote doing this, because you can't, when you're in the middle of it, you can't have a distraction, because it's gonna mess up your results when you're taking notes. And so really just after those 3 weeks, it was just like part of the day would be like, I'd do the thing that I didn't want to do in the morning, which was get all the jobs done first, do all the things you hate doing, or not hate, but aren't as stimulating.
It feels like hate when you're pulling yourself away from something fun.
100%. And then do that towards the end of the day. So that was really it. And my wife telling her, I'm sorry, not going to make it home on time.
Right. Yeah. I might be a little distracted when I'm home because I'm just thinking about this thing. Yeah.
Actually, I owe it to her for figuring this out, because I was just at home one day and I'm like, there was another part I was working on. I'm like, man, what did they paint this thing with? What is the paint that they used on this? And I'm sitting there, it's been like a week, and I'm like thinking about this every night. And she goes, maybe it's not paint. And I'm like, maybe it's not paint.
Oh, that's awesome. Let's see. Both Dylan Tanner and Alex Kern asked, what's the most difficult part of a watch to make?
So it's not one, but there's a few. You have the balance wheel. The hairspring's impossible. You're not going to do it unless you have like $5 million of investment money to get the wire drawing machines, etc. So like actually, tempering them and drawing them, it's impossible. Balance wheel can be done. It's hard. The escape wheel is harder because they're chemically etched.
Oh, really? I didn't realize that.
Yeah. So they're hard already. And then the hardest part actually isn't that, it's polishing. I think it's a 15-degree angle on the bottom side of the teeth. And to get a setup where, if it's like 15 teeth, they all have to be perfectly polished at the same angle. And you could do it, I guess, like on a Shoblin, but the smaller the gear or the wheel, it's just very challenging. So I would say that part, and then the barrel is really hard because you're fighting tooth form, concentricity errors, and there's also two errors that are going to tolerance stack: the lid and the lower diameter. And there's an outside and an inside diameter, and then just the tooth profile, like the roots, the teeth. So that's a pretty challenging part.
The surface finishing that's done in watchmaking is, to me, the most astounding stuff. Like seeing you or Josh like polish screws that you can barely see with your eyes. Like it's so cool, and yet like just so insane to me that like every single thing is polished. Like there's not a surface left untouched in a watch, it seems like.
Josh has got some pretty wild parts that, I mean, especially like his main plates, the Timascus. One of the coolest things. Like that is so different. And then his screws, the way that he figures out how to polish them efficiently. I mean, it's so challenging when you're finishing
Right.
parts.
Yeah, it's the efficient part, because like I think
Yeah.
anybody could sit there and scrap a million parts and figure out how to polish, one watch worth, but to make that process repeatable and not take a year, like that's the secret sauce, it seems like.
100%. That's it right there.
Let's see. Another past guest of the podcast, Ethan Patain, asked favorite miniature part you've ever made and favorite feature on the Kern.
Favorite miniature part is definitely a balance wheel. That's a fun one. Really challenging, out of titanium. And
that's cool. So what made
yeah.
you choose titanium?
So I wanted to be able to have it light enough to match to an existing spring. And then there's 4 posts, or no, there was 8 on this one. And was going to use gold weights on around the rim that are semicircle or half circle. So you can position them to shift the weight around on the balance when you're balancing it dynamically. And anodizing, being able to anodize it a certain color.
Makes
the
sense.
issue was it was half the weight of the brass one. So it was too light and the spring wasn't appropriate for it.
Oh, interesting. And you can account for that with more weight on the outside?
No. Even the weights being made out of gold were 0.002 grams. So, and I was off maybe like 30 grams.
Oh, wow. Yeah,
Yeah.
that's night and day.
Not 30, 0.3, sorry.
Okay. I was like, that's like everything.
Yeah, it was off quite a bit. I think it was 0.3, maybe 0.03. I don't know. It was like,
It was
probably
enough.
a year ago. Yeah, it was a significant amount.
Yeah. Let's see. IGS Dan, he said, how did you get so skilled at fixing machines?
Just, I needed a way to make a part. I didn't have money, and just I had to do it. So, using the electronics knowledge that I had, and just applying it with common sense to how a CNC machine works, and just really looking at industrial machines and seeing how they design them, and just kind of reverse engineering stuff that I already had helped a lot.
Okay. If you were trying to help someone now rebuild a machine, are there any basic literature or resources that you would turn them to first?
I would say start with a machine that already exists and understand how it works fundamentally. And once because that's what I did. I mean, there was a basic control on my machine, but they were all Chinese parts, like a Chinese motion controller, really crappy steppers. The brackets were terrible. So at least having that, I understood like the basics. What are limit switches? How do steppers work? What drives them? What controls the motion card, etc. So I would say start off with something that exists, even if it's like the cheapest eBay CNC machine, and then work your way back from that and maybe find a way to make it better. So instead of using steppers, use servos, or, lead screws, use ball screws. If you're using lead screws, just Google.
What about the digital side? Because you've talked twice now on 2 different machines that you've had data recovery done or cloning drives. Like, where did you even think? Like, I would never even have thought like, oh, let me find another Keyence and clone the, mirror the drive. So what kind of started you down that?
So I had a lot of prior experience as a kid. I was pretty much a loner growing up when I was young, and I'd spent a ridiculous amount of time on computers. I was fascinated with how they worked. Quickly learned that there was something called Linux, and went down that rabbit hole. And this was like early 2000s, so like it was like Red Hat Linux and just CentOS, I think. So anyways, I learned a little bit more about how like hard drive data worked and how to clone drives using like DD in the command line. Familiar with it, or and then something with a GUI is gparted. So then understanding how that worked and how you could recover data or segments of it. There's people with labs that have dedicated computers with PCI cards that can actually go a little bit further than you could do just interfacing it with USB, for instance. And having that knowledge was like, where is there a lab in Ohio that has a data recovery, the data recovery place that has a lab? And that's what I did with the MCOs. But the Keyence, I think it was around $15,000 to get a new control from them, or just to send the control back and have them fix it. So I was like, yeah, I already have quite a bit of money invested into it. Right. If I was going to spend another $15,000, I'll just get a brand new Keyence at that point.
Right.
It just doesn't make sense with the service. And so it just made sense just to clone it. And I used Linux to DD, if that drive of the other one, BS equals 1M, and then just wait until it all transferred over. And
that's awesome. It was. That is super cool. So if somebody was looking for a data recovery place, what should somebody look for like a good one? Because there are a million. Like if you go online, there's, I don't know, pages and pages of Google results of places that you can send your stuff. Like what do you look for? What capabilities do you look for in a data recovery place?
Ask them if they have a lab on site.
Okay.
Normally they send it out. If they don't.
Oh, okay.
Most places send it out.
Very interesting. Okay.
Yeah. What's cool is you might be able to talk to someone there that's going to know every step of the process, and it's going to save you a lot of time.
Okay. That's great. His next question was, what are your goals and aspirations for both the watchmaking side of your business versus the job shop side?
So the watchmaking side of the business, I want it to run independently. I want to hire a manager. I have a guy who's helping me part-time. So get 2 watchmakers in here, manager, have this kind of be where I can just at the end of the week come and, or maybe at the end of every day, and just get a report and see, if there's any problems that require my intervention to come into. So this side of the business is important because this is my cash flow side of the business, paying monthly bills or day-to-day, things. I rely on this, on the service business, versus the job shop side of the business. It takes longer to get paid, as I'm sure everyone knows. So that's more of a long-term goal. I'm very early on the job shop side, business-wise. So I would like to get more involved with diversifying the business. So there's not really enough watch parts to make in the US, at least in production numbers. And people get sticker shock when you tell them how much it's going to cost to make something, because no one knows about losing money on programming, right?
Right. Yeah. Nobody knows what anything costs anymore.
So it's not losing money on programming the parts and being able to charge as if you respect your company and yourself. It's challenging because people look at a price and they're like, heck no, I'm not gonna. So watch parts, there has to be enough quantity, and making parts for 5 of them or 2 of them for a watchmaker doesn't make sense. Making stuff in-house makes sense for the reason of consistency. I can measure it all out and I can hand it to a watchmaker and know that that part is good, and that's not going to be something in the process that's going to waste his time. So he'll be more productive, and then the shop will be more efficient. So that's really the view of making parts here. But diversifying is really the goal for the machine side.
Okay. Let's see. Adam from Laney College had a lot of questions about your machines. First was, how did you bridge the gap between watchmaking to machining? So I mean, obviously you were trained in watchmaking, but that's a very different type of machining. And even with your job shop experience, were there some teething issues kind of jumping into this medical stuff?
I think just understanding like what the expectations are. So the format that they want things in, and getting more certifications, like eventually getting ISO, and, just understanding the way that the shop is supposed to be run uh, from a perspective of someone who is involved in a medical company, and that's really, I see being the biggest challenge. And I would definitely get someone in here to help me out with that, because it's a recipe for disaster if I was going to try and do that by myself. There's just no way.
Definitely. Yeah. His next question was, what are the 5 most important things to keep in mind for successful micro machining?
Probably choosing the right parts to make. That's a hard one. Being able to look at a part and knowing if it's going to be a total nightmare down the line, even when it looks simple, just to be really careful with what jobs you decide to take in. And that's been a big learning experience for me. I've lost a ton of money taking in the wrong jobs. And you're like, oh man, that looks easy. That's going to be fun to make. And surely enough, it becomes you're paying the customer to make the part.
His next question was, what are your thoughts on the free dissemination of information related to watchmaking and the general secrecy of watchmaking in general?
So it's tricky. There's people who have paid a lot of money to get the information they've learned, such as myself, who have been blocked out of the industry because nobody wants to share stuff. And that's really frustrating, but also really motivating, because when someone tells you you can't do something, if you're like me, I'm like, yeah, watch this.
Watch me. Yeah.
Yeah. So I think it's good and bad. It's bad because when you die, the secrets die, and that's only going to cause the industry to die. So I think there's a balance. Like if it's a trade secret where it's giving you an advantage and it sets your brand apart, then by all means, like you should be able to have that secret that's your advantage, right? But to keep the whole industry and just to be a gatekeeper to keep people out, I think is a little unnecessary, because the more people there are in the industry, the more awareness there is, the more jobs there will be in the future. So it's kind of like if everything, if the water rises, all the ships rise around you, kind of a mindset.
Yeah. I noticed that. I kind of got, I went down the rabbit hole of a little bit of watchmaking and took apart some watches and stuff. And then you start looking for like just simple information, and you're like, I don't even know where to start. Like I reached out to Josh, and like he was able to point me in some directions and stuff, but it's like there's just so much that is guarded information. It's really tough.
It's also really tough for one person to share all their information, because it's so many years to unpack. Like,
oh yeah. Well, it's stuff you don't think about it too. Like,
yeah,
if somebody asks me, how do you become a machinist? It's the things that you don't even think are machinist things that you need to pass along, and then you realize a week down the line or a month down the line, oh, I need to tell you about this.
100%. It's the exact same thing. It's like 10 years of information. There's just no way you're not going to remember how to unpack it the way that you learned it. It's
right.
just,
yeah. Well, I know Adam's working on that open movement project. I think he's been making it on his Kern.
Okay.
I thought that was super cool, that like there's an entire movement with drawings and models and all that you can kind of go into now.
Yeah, that's a great starting point. I mean, just to have that information out there, it's a pretty big deal.
Oh yeah. His next question was, what are your future plans for the MMT and HSPC?
So the HSPC runs oil. The MMT does not. And really just creating a workflow for separating the two different parts that, you may not, like if you're going to machine plastics or you're going to machine something that you don't want oil to touch, will be on the MMT. And I'll be able to simultaneously run both machines is the goal. I still have some improvements to make. I need to get a rotary screw compressor, because the MMT just uses a ridiculous amount of air. Crazy. I think it's like 7 or 10, maybe it's 12 CFM of actual. It says minimum of 7, but it's
That's a
probably more.
ton for a tiny machine like that.
Yeah.
And then his last question was, would you attend a vintage Kern meetup with him, Peter Doble, Josh Shapiro and his crew, and anyone else with pre-hydrostatic Kern?
I don't see why not. As long as the time lines up. It's tricky to get away from the business.
I totally understand, for sure. And then the last question from Wannabe Machinist, he wanted to hear us discuss, do you label it as op 1, 2, 3, or op 10, 20, 30?
Op 1, 2, 3.
Okay, I'm the same way. He was also, and I told him, so the last job I was at, we used 10, 20, 30. And the reasoning I was told, and it was a production shop, is that if you ever have to add a in-between op, it's much easier to add 15 between 10 and 20 than it is like 1.5 or something. And I was thinking more on this last night, and I realized the reason I use 1, 2, 3 is that for me, like I might have a rough outline of how a part is going to go, but it's brand new to me. So if I need to add another op, it's just op 5 after op 4 or op 6 after, there is no in between ops anymore. So I can understand the 10-20 thing, but yeah, I'm 1, 2, 3, it made sense to me. The funny story that brings up is that when I first started at that job, I had come from a job shop. We were using op 1, 2, 3, and I was in inspection and I was asking them something, and he was like, oh, this is op 20's part. And I was like, it takes 20 ops to get to this state. I was like, you guys are so slow. Like, how does this work? And he's like, what are you talking about? It went back and forth, and finally I was like, oh, no. This is the second op. We go 10, 20. And I was like, oh, okay, that makes a lot more sense.
Damn,
but I'm sitting there. Yeah, I was like, what are you doing? Like 1 hole per op? Like, this is stupid.
Man.
Well, that brings us on to shop news and new things. What is new in your world? Anything, big? Any programming things you've done recently that are cool? Whatever is just fresh and present.
Yeah, so been working on making these bridges the past week for a movement called a Valjoux 72. So it's a vintage caliber chronograph, and it's used in the original Rolex Daytona. A lot of really high-end watch brands use this in the early days, and parts are slowly going away for it. So little by little, I'm going to make parts for it. I love the movement. It's a really nice movement to work on, and just basically going to improve some things on it that should have been improved a long time ago.
Okay. So are you kind of keeping an eye on the watch market and seeing what watches are popular and that might need parts in the future? Or are you just relying on customers to come to you and say, hey, I need this part, and then realizing that there's, no stock of it anywhere?
So generally, I don't wait for a customer if it's another watchmaker, unless it's enough of a problem where I can see that it's a good production part. I use my experience the past 10 years just working on stuff to know what breaks and just start making those parts, especially when you see them going away. So some of those parts still exist, and people are like, why are you making this part? And sure, it exists now, but in a few years, it's gonna, the spare parts are gonna diminish. So it's more of just finding parts to make that I've already worked on the movement, I'm familiar with it, and movements that I like that are actually nice movements, not just production watches that don't really have any value.
So what makes a movement nice to you? Like, what makes you like a movement versus not like a movement?
So how does it run for, if it's vintage, like it's 50 years old, how does it run for the past 50 years? And like, what materials did they use in it at the time? So materials has changed quite a bit. So now you have R&D departments that are figuring out how thin can we make this wheel? What's the best material to use to reduce wear on tools? And back then, it was just like, what's the way we can make this to last the next lifetime? And if there's like a nuclear war, the watch is still going to work, basically. It's just like overbuilt,
Right.
So those would be watches I'd qualify. That's like the first thing, right? So how does it run? What are the materials it's made of? What does the finishing look like on it? You mentioned that. So what qualifies good finishing versus bad finishing? And when you look at different grade watches and you look at it under the loop, you can look at the polished surfaces and see if, grain, like straight grain, crosses over into those surfaces that it's not supposed to. So, et cetera. That's like a whole nother topic of discussion. But so how are the parts finished, and what's the desirability of the watch in the market, right? So if there's enough people that value that movement, or the watch rather, then the movement holds value, and you can charge enough for the parts. So it's hard, right? Like how do you charge enough for the parts, especially if the watch isn't worth anywhere close to what the part
What
cost.
parts were right. Well, that brings me to the last question I ask every guest every week, which is, what did you research this week? Doesn't have to be watch or machining related, but just what's been popping up in your browser.
Probably just ways to organize the business, and it's maybe less of what's in the browser, but more on spreadsheets and just kind of figuring out how to keep things organized. And
Okay. So are you looking into ERPs or anything along those lines, or
not
you're
yet.
pretty happy with the spreadsheet so far?
Spreadsheets okay, but it's going to be a problem in the future. So ERP might be on the horizon in the next year.
Okay. What have you found has been the best thing that you've implemented in maybe the last year to keep things organized?
Probably using a algorithm, or just like in cells, nothing crazy, but like and if statements and cells, just to be able to categorize things. So knowing how many jobs are where and where things are, and like the status of the job, and color coordinating it. So it just takes a lot less time to find things. And that's something that I'm trying to be more conscious of, because I'm very ADHD. So naturally that comes, with that, it's being disorganized. So I'm making it a point to reduce clutter. And that's one of the areas that can definitely be improved. So that's been my top priority lately.
Okay. Well, thank you so much for taking the time. It's been super cool to hear, your machine fixing stories and how you kind of made your way sideways into the industry. It's a very awesome story. I really, really appreciate it.
Thanks so much for having me on, Dylan.
My pleasure. And thanks to all the Patreon members. I started a new workflow this time. I hope you guys like the audio. Instead of sending out a cheaper headset, I kind of put together a little mic and headphone set and sent it to Zach, and he was able to get it working, thankfully, with very little issue. So hopefully it was better. You guys all made this possible. Thanks everyone for listening, and I'll be back next week.